Today we're going to review the measures of variability. Now when you look at this word, it's a big word, but what you might see inside of that is that word vary. And it's basically doing exactly that. It's saying how does the data vary, or what we're going to really talk about with variability is this idea of spread. Okay, and just to kind of review here on the side, I just want to remind you that there's a couple different things that we've already done. We've talked about shape. Shape is things like clusters and gaps and just kind of what does it look like? What's the shape of the data when you put it on a graph, for example? And then the other thing we talked about was these measures of center. And measures of center tend to get us to like what's typical, what's the middle, like what, if you looked at the center or the middle of the data, what would it look like? So when we look at variability, we're looking at the spread, and this is different, and we look at it for different reasons. And there's really two different kinds of measures of variability. So I'm going to split my paper in half. There is range, and then there is something that we call the interquartile range. So there's a similarity between them, but they're slightly different. Okay, so range is really, it's the idea of taking your highest value and subtracting your lowest value. And it will tell you how spread out your data is. And we'll kind of talk about, well, how do you know if it's spread out or not spread out? Unfortunately, that has to do with the context of the situation, so we'll talk about that. Whereas when we get into interquartile range, it's still a subtraction situation, but instead of taking the highest value minus the lowest value, you actually take what we call Q3, which is really the median of your upper half of data, minus your Q1, which is your quartile 1, which is the median of the lower half. So it's still a range, it's just what interquartile range is doing is it's really getting rid of your extreme values on either end, and it's looking more at the middle data. I like to call it the middle range, okay? So we're going to look at that in the context of a situation. All right, so pretend we went around and we asked different people, how many siblings do you have? And we received the data that you're seeing in the dot plot below. And this time, again, we're not necessarily looking, if we looked at the shape, I would see a couple different things. I might say, well, gee, it seems like there's kind of a cluster right here. A lot of the people's data is sort of falling in this 1 to 2 range. I could go ahead and I could find the median and I could find the mean, which again would be showing me that sort of that measure of center of like what is typical. I can also look at things like gaps. I do see that there's a little bit of a gap. It's a small gap, but there's a gap between 4 and 6. So I can look at all those things that we've already discussed. But today our focus is how spread out is the data. Now you might already be able to tell visually by looking at the shape of this graph. You might even say, well, I don't think it's that spread out. It's not like we have somebody who has 20 siblings here. There's a huge gap in what we're looking at. But we're going to find a single number today that's going to help us describe that variability. So again, just like before, we're going to kind of split our paper, and we're going to find both range and interquartile range. Now remember, range is the highest value, in this case 6, minus the lowest value, which is in this case 0. Okay, and my answer is pretty quick to get, and I get 6. Now you might be saying, well, that's not a big number, so it must not be really spread out. Well, here's the thing. You have to really look at the context of the situation when you determine if that 6 is big or small. You have to look at what could have been the highest range I could have gotten. Well, the highest range I could have gotten was 6, and the lowest range I could have gotten was 0. If the highest number was 0 siblings and the lowest number was 0, I could have gotten 0. Or in this case, I could have gotten 6. So because the highest value I could get is 6, the range is really showing us that this data is pretty spread out because we have every possible, this is kind of tricky. I shouldn't say that. The highest number isn't necessarily 6, so I'm going to have to take that back a little bit. The highest number could be infinity. Somebody could have 200 siblings. Somebody could have 1,000,000 siblings. Is it far-fetched? Yes, for sure. So in this situation, it's kind of hard to decide if it's really, really spread out because we really could have had much bigger numbers. So I'm sorry for that little bit of an error. But if we come over here to IQR, which is going to be, so we're going to be over here, and we're going to be on our IQR. Interquartile range is also still a range, but again, it's looking at that middle value. So what I'm going to do in this case is I'm going to take actually make numbers to my situation here. I have one person who says 0. I have 3 people that said they had 1. I have 4 people who said they have 2 siblings, 2 people that said 3, 1 that said 4, and 1 that said 6. So this is my data values in order. And again, what I'm looking for is kind of the range of the middle. Okay, so when we do this, we actually find 3 different values. We're going to find what we call quartile 1, quartile 2, and quartile 3. Now, I have, let's see, it looks like I have 4, 7, 8, 9, 10, 11, 12. I have 12 different data values. So the first data value I'm going to find is my middle. So I've got 1, 2, 3, 4, 5, 6, and then this would be my middle value. There's nothing there right now because I have even number of values on either side, 6 on each side. But because I'm in the middle of 2 2s, my Q2 is going to be the number 2. And what Q2 is really just another word for our median. Okay, we would find that with our measure of center. So our median is 2. That's our measure of center. That's sort of typical, is 2. And now we're going to find the median of the upper half and the median of the lower half. So what you're going to see right now is that you have your lower half here and you have your upper half here. And we want to find the median, like what's the center of each of those halves separately? Because on the range side, we were just saying, hey, the highest value is 6 and the lowest value is 0, and now we're going to go more for the median. Now what you're going to see here is that I have 6 values on the lower half, 0, 1, 1, 1, 2, and 2. So again, I'm finding the middle of that. And again, the middle is going to be right here in the middle of these 2 1s, and I'm going to call that Q1, which is really the median of the lower half. And to find Q3 is just the median of the upper half. So I've got a 2, 2, 3, and then a 3, 4, 6. So this is going to be the median of my upper half, which we're going to call Q3. So what I'm seeing now is that to find the IQR, it's really taking Q3 minus Q1, which in this case is the number 3, minus the number 1, and it's giving us a 2. You're going to see a significant difference here. So when we found the range, we found out that it's spread out 6 people. There's a range of 6 people in between. But now there's only a range of 2. That's a lot different. So the IQR is kind of what we call probably a better measure of variability. Just like we said that median tended to be a little bit better than mean, a little bit less resistant. You're sort of seeing the same thing here. On the range side, it's really keeping into account those extreme values of 6 and 0, but when you're on the IQR side, it's kind of getting rid of those and saying, let's just look at the middle of the data. Let's see how spread out the middle of the data is. And we got 2. It says there's only, again, that doesn't mean 2 people. It just means that there's only a difference of 2 between what people said. And so this tells me that our data is pretty close together, which means that most people were saying very similar values. And when you look at the data, you see that. Again, if you look sort of here in the middle, you're seeing that 1, 2, 3. Even 4, there was only one person that said they had 4 siblings. So in an American society, it's more typical to have 1, 2, 3, but it's also showing us that the data is very close together. People said very similar answers because we got rid of that 6 and that 0. I'm going to just do another example really quick, and I'm going to pretend that this is I don't think this is the exact data we used in the last video, but it's the data, we're going to say this is data for homework slips again. And I already ordered it, already put it there, and I have 0, 1, 1, 2, 2, 2, 2, and a 20. Okay, so again, if I'm looking, again, I'm not thinking about measure of center here or what's typical. I'm really looking at this idea of range versus IQR, and I'm really trying to see how spread apart the data is. Now, if I look at the range, again, I take my highest value, which is 20, my lowest value, which is 0, and I find out that there's a range of 20, meaning when I asked people, there was sort of the data spread out 20 different numbers, which to me is a pretty high value. But when I take the IQR, again, I'm taking that same data, and I'm really going to look at the middle. So again, I usually find my Q2 first. Now there happens to be, let's see, 4, 5, 6, 7. There's 8 pieces of data. That means I need 4 on each side. So this is really going to be my Q2. Q2 is a number 2. That's the median. Then I'm going to look just at my lower half and just at my upper half. And I'm going to find Q1, which is right here, which I'm getting a 1, and Q3, which is right here, which is a 2. And now my difference between my highest and my lowest is 2 minus 1, which is 1 again. This is a huge difference. Now it's telling you there's only a difference of 1 between the values that people gave us. And so this shows you it's not very spread apart. It's not spread out at all. If we get rid of those extreme values, that 20 and that 0, you can even see it here. People typically said 1 and 2. It's not very spread out. What people said is not very spread out. But if I looked at the range, it is very spread out. And it's because of that 20. So again, we're looking at spread, and when we're trying to decide which one's better, is range better or IQR, IQR is just more representative. It's getting rid of those sort of extreme values. And it just happens to be a little bit better. So remember, IQR and range is how spread out your data is. Measure of center is sort of what's typical. And then your shape is just really what does the data look like.